have a few questions, okay? So I think today is the 5th. Okay, so what type of equation is this? Every time I'm asked to solve an equation, we did not start, we're just working on some questions. So every time I'm given an equation to solve, I will ask myself, what type of equation is it? I have to, because as we know, every type of equation is different, every recipe is different, every method is different for different types of equations. Okay, so what will you say? A rational equation because it has fractions and the denominator has x. Otherwise, if the denominator does not have x, even if there are denominators, it does not have the variable, then it's not rational. But this one is rational. Good. So what will be the next step? The next step, I highly recommend write restrictions on the variable. So here I have one denominator. So from here, what will I say? X cannot equal 0. There is no denominator here. If you want, there is, but it's silent. And now I have 4 times x. And when I write 4 times x not equal 0, and I divide both sides by 4, I get x not equal 0. So this is the only restriction. So the only concern I have is when I'm done with this equation, and let's say I get 2 solutions, x equals 0 and x equals 5. X equals 0 is not accepted because it was already taken out. The next step would be very good, but not before I move everything to one side, if in case you like this method. So I have 4 over x minus 1 over 4x minus 3 over 1 equals 0. Yes. So one more time, first I identify the type of equation and it's rational. The second thing I ask myself, if it's rational, I have to state restrictions. And I did. There is only one restriction, x not equal 0. Then the next step is I move everything to one side and there is 0 left on the other. Now, yes, I will have to find the least common denominator. In order not to forget the equal symbol and 0, I draw a long fraction line and the equal symbol and 0. And then I'm asking myself how many different factors I see here. I see x, I see 4x, and I see 1. How many different factors do we see? 2 different factors. 4 is a factor, and x is a factor. 1 you can consider the third factor, but 1 is not going to affect anything. So if we have 2 different factors, the denominator, the least common denominator has to have those 2 factors. Then, what is the next step? This is a rational equation. I cannot just simply add the numerators. I have to make the corrections. So if I started with x and I have 4x, then the correction is 4. So if you go through the video step by step, you will hear me say all these steps. And if you watch that particular equation 5 times, if that's what you need, or 3 or 2 or 6, then you will understand and you will get in your system. You'll see how it's becoming easier and easier by simply going through those steps. Okay? So x was multiplied by 4. The numerator has to be multiplied by 4. 4x was not changed in any way. If you want, if you feel comfortable, you can write 1. And 1 was changed into 4x. Oh, well, obviously, I have to multiply the top by 4x. Also remember to look at all examples in the book. We can do here everything, but still the discovery process is the most important. I told you, I gave you that example when people who know this silly game that I'm playing and blah, 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 I was like, what are you talking about? I have to go home and open the book and do the examples until sometimes it does, sometimes it doesn't. So it's not that easy. I'm telling you step by step, but you still have to work on the problem and go through the discovery process. Okay, so 4 times 4 is 16, minus 1 times 1, which is 1, minus 3 times 4x, which is minus 12x. Combine like terms, 16 minus 1 is 15. 15 minus 12x over 4x equals 0 over 1. Let me point out that a terrible mistake would be for me to simplify this x with this x, or the 4 with the 12. That would be a horrible mistake. So now at this stage, I know this is a proportion. I worked hard to change, quote unquote, I worked hard to change this equation from a rational, complicated, if you want, equation into a proportion. Now everything is straightforward. These two multiplied will give me 15 minus 12x. These two multiplied will give me 0. Now this is a linear. I move 12 to the other side and divide by negative 12 and I'm done. So x will be negative 15 divided by negative 12 because I move 15. So I will simplify by 3 and I get 5/4.
I get it.
So this is the key. The key is to, that's why I'm doing all this. That's why I'm taping everything for you, and that's why I post these notes. Whatever you throw at me, it's going to be on a paper, and I connect it to the video. Because I know for many of you, like it is for me, and these people who have 40 years experience in something, and they tell me, oh, it's easy, blah, blah, blah. I don't know what they're talking about. The same thing with some of you. Although I go step by step, although I think I go slowly, but for some of you, it may not be slow enough. That's why I post everything for you to go back and redo these things. Very good question. Is this clear? Mm-hmm. However, we looked at 2 examples. Will 2 examples be enough to master solving rational equations? No, most probably not. That's why we have to go back and do all these. So what I think is extremely important is for you to go back to the book, the ebook, and this is what I would do. After I redo the lecture notes as many times as I need, till I put them aside and say to myself, let me write these 2 problems one more time and do them on my own without looking anywhere. After that, I will do this. I just opened it somewhere because we're going to get to this today. Solving a polynomial equation by factoring. I will follow through and see if I get the same solution. So please come in if you're in this class. If not, you're still welcome. Example 3. I will go, bless you, I will go through all these steps and make sure I understand everything. Then example 4, and then example 5, and then example 6, and example 7, and example 10, and only then I'll say, okay, now, bless you, now I am ready to select from the homework list of problems 10 problems from this section, check the answer in the back. And then I will say, look, I redid all my problems. I am comfortable now. I did all the examples in the book and some odd number problems from the recommended problems. I should have no difficulty with homework now. And if I still have difficulty, I'll say, well, maybe I didn't study enough. Maybe I should go back and redo several. Yes, this is how math works. I know you're busy. I know that this is not your only obligation in life. But if you want to be strong in this class and acquire the material, this is what we need. Yes, please.
Can you go over the problem?
Any problem?
Yeah,
absolutely. Hold on just one second. Is anyone has any questions on this problem? Do we have any questions on this? Okay.
I have a problem.
Sure. I will get to it in just one second. Is there anything else that you wanted to ask?
I had a problem with all of those problems, so I'm going to
with the rationals.
Yep.
Is this now step by step clear?
Mm-hmm.
Okay. Yes, please.
3 over x equals 3 over 4x plus 3.
Okay. So let's go back to this one that we just did. I'm sorry?
I walked in late on that one.
No, that's okay. No, you are not late. We decided to start a little bit early with a question. So maybe because other students came in right now, let me just verify this. 3 over x equals 3 over 4x plus 3. Is this correct?
Yeah.
Okay, let's do this. Forget about the first one. So the first question I ask myself is, every time I'm given an equation, I'm going to ask myself, what type of equation is it? because different equations have different recipes of solving, right? Okay, perfect. So what type of equation is this?
Rational.
It has a fraction, it has x in the denominator, so it must be a rational. Always remember, I know some of you just came in, you must redo the problems we do in class first. If you don't do any work and you say, okay, I'm going to start homework, it's not going to happen. You're going to get a hurdle or to a brick wall from the first problem. Because you need to practice and you need to redo the problems first that we did in class. Okay, so it is rational indeed. Rational equation. What would be the next step? What do I have to do next? I have to state restrictions. So this cannot be 0. 4x cannot be 0. If I divide both sides by 4, I get the same thing. X cannot equal 0. So this is the only restriction. So if at the end of the day I get that x equals 0 and 5, I will say 0 cannot be, and 5 is the only solution. Yes, please.
Is this what you expect, like, in an exam?
Absolutely. Step by step. That's why I write it. That's why I say it. That's why I post it. That's why I scan all the papers that I write on. Yes. For full credit, everything. Yes.
Like, we have to write, like, the restrictions part of it?
Exactly. It's part of the problem. Yes. 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 Now, you can say to me, there is a different method in the book, and I prefer the method in the book. I'm fine. But you have to show me the method from the book. Okay? So you have to present a method from the beginning till the end, like I'm doing it here from the beginning till the end. If you have a different method that you're comfortable with, forget about mine, but you have to show it to me step by step. You cannot say, I used the calculator and I got 5/4. No, I can't give any credit for that. You can, yes, you can say, I don't like your method. I don't like the method in the book. Somebody in the math lab showed me a third method that I'm comfortable with. I'm fine. Don't use mine, don't use the books, but you have to show me step by step everything you come up with.
The reason why I'm sorry.
No,
the
go
reason
ahead.
why I'm saying this because I mean in my mindset I'm trying to learn your method, which is fine.
If you like it. But if you know another one that works for you, I'm fine.
Yeah, because going through like writing rational equations and all this, for me, like I said, I'm trying to get through it. But it's kind of hard for me right now. But I will know how to like walk my way
That's
down.
why I post everything, because as I mentioned before, for some, I know this is fast. For others, this is very slow. I have to somehow not lose people. Yeah, I wanna move forward with everyone. I wanna help everyone, but at the same time, I also have to finish the material. Sorry about the wait.
You answer my question.
I did already. Oh, good. Other questions here so far? Okay. So the only restriction is x not equals 0. Good. Then, if you're using my method, I would recommend do this. Move this term and move this term to the other side. Once I move a term from one side to the other, all that changes is the sign, as we know. No cell phones. If you have any cell phone, I don't want to see it. If I see it, I will be asking you a question. You will come up to the board and you'll solve a problem for us. If I see your cell phone, you will be invited. Okay, so the next step is indeed finding the least common denominator. And in this case, there are only 2 factors, right? X is a factor, 4 is a factor, and this one, if you want 1 is not a factor. It is a factor, but it does not change anything. That's I should have said correctly. So what is the least common denominator in this case? Very good, 4x. Remember, adding and subtracting fractions requires that if you change the denominator, if you take the liberty to multiply the denominator by 4, you must multiply the numerator by 4. You can't just get away with that without multiplying the top. If you multiply the denominator by 1, you multiply the top by 1. If you multiply the denominator by 4x, you have to multiply the numerator by 4x. That's how adding and subtracting fractions works. So, or work, both of them. So this needs a 4, this needs a 1, or you don't have to write anything, and this one needs a 4x. The next step would be to, anyone can help. The next step would be to not simplify, but combine like terms, but you have to write them first. 4 times 3 is 12, minus 1 times 3, which is 3, minus 12x. Do we agree with 12 minus 3 minus 12x? We do or we don't? Yes, please. Everything, everyone? Yes? Yes. Okay, so now I have to combine like terms, and I get 12 minus 3, which is 9 minus 12x divided by 4x equals 0 over 1. Again, this is only if you are using my method. Now, we worked hard to change that equation from a rational equation into also a rational equation, but this time this is a proportion. And this is very convenient. What I can do here, I could have not done over there because of the 3 terms, right? But here we have one fraction on one side, the equal symbol in the middle, and one fraction on the other. That is the requirement, or this is what we call a proportion. So now I can cross multiply. And what I get is this times this is itself, and this times this is 0. Now this is a linear equation, so then negative 12x will be negative 9, and I divide both sides by negative 12. So this is 9 over 12. I'll simplify by 3 and get 3/4. So remember, that's your first step. This is your first baby step. The first baby step is to watch what we're doing here several times till you understand and you can reproduce those solutions step by step on your own. Then the examples that I showed you that are solved in the book, the problems that are solved in the book. Step 3, odd number problems from the end, from the list of problems. Where is my list of problems? Right here. I will start checking these. So you have to have a notebook in which you present at least half of these problems for each section. If you don't, and like at the end of the semester you say, I don't know why I'm failing, then I'll say, look, I don't want that to be the case for anyone. So I want to see on Monday half of these problems, half of these problems, and half of these problems. Okay, because we're going to finish 1.5 and start 1.6. This is the only way you will build your confidence in your skill in this class, and then you'll say it's easy. But if you don't do that, it will always be hard. One other thing is, I'm here early in this room. I have a class before yours that starts at 2 o'clock and ends at 3 something something. So I'll be more than happy to form a study group to help you, sit down next to you, and answer your questions. Every time. Monday, every class, Mondays and Wednesdays. So if you're coming from DC and you can get here before 5, you can get here before 5. But if you can't get here before 5, I strongly recommend we'll sit down and we'll form study groups and we'll work on problems so we can make headway. If anyone is interested, I'll be here anyway. Any questions? Any questions? Okay. Is there anything else you have for me? Yes, please.
Can you cut that front light off?
You turn it on?
I'll cut it off.
Off. Oh, okay. Is this better?
Mm-hmm.
Okay. Sorry about that. Good. Anything else? Do you have anything else for me? Did you try anything else? I'm happy to see that you tried. I'm very happy to see that you tried. Yes, anything you want. Just tell me what you want me to do.
I don't have it written. Hold on.
So if you work in my math lab one more time and you come across something, there is no way I can show you every type of problem in 2.5 hours per week. I can't do that because I also have to explain, I also have to talk to you. So there is no way. If you come across something that you have not seen in class, just take a picture with your cell phone and show it to me and bring it to class. Okay?
Can I just give you my book?
Yes. Any problem. So which one we want to
Like
look
99
at?
A, B, and C.
99 A, B, and C. Very good. Okay, very good. So let's take a look at this problem. Okay, so the line graph shows the cost of inflation. What cost $10,000 in 1984 would cost the amount shown by the graph in subsequent years. Okay, so I see the cost of inflation. That's the title of the graph. I see cost in thousands of dollars, and I see year from 1990 till 2013. I see when I look at this graph, thank you so much for bringing this up. Can you see? Is it clear or is it blurry?
It's just underlined.
Is this better? Better? Okay. So what else I see in this graph? I see an uptrend. I see this point, 13,100. I see this point for X. I see this point. No, actually it's for Y. They normally should present both ordered pairs, but it's fine. It's clear. 1990, sorry about that, and 13,100. 2013 and 23,300. Clear. What cost you 10,000 in 1984 would cost you this much in subsequent years. Okay, good. I analyzed the graph. I don't know what they want me to do yet, but I have a very clear picture. It's an uptrend. I'm looking at year. I'm looking at cost in thousands of dollars. Then, here are two mathematical models for the data shown by the graph. In each formula, C represents the cost C years after 1990 of what cost 10,000 in 1984. So we have model 1. It says C equals 442x plus blah, blah, blah. And model 2, C equals 2x squared plus 390x plus 13,000 blah, blah, blah. Use these models to solve exercises 99 through 102. So we are only looking at 99 A, B, and C. That's the question here. Okay. Now, which of these two models do you think makes sense and which one doesn't really make sense? Before I even read the question.
Model 1 makes sense, Model 2 doesn't.
Why model 2 does not make sense?
It's going to have
Because?
the exponent.
Oh, right. Because it's a parabola, not a straight line. So I don't know what they want with model 2. I didn't even read the problem. But for now, I can already say that to myself. This is definitely a linear function with a positive slope. And this is definitely a quadratic function that opens upward and has a minimum. I don't even know what's in there. We'll see in a moment. Okay, use the graph to estimate the cost in 2010 to the nearest $1,000 of what cost 10,000 in 1984. So use the graph to estimate the cost in 2010. I go to 2010. I imagine that I draw a vertical line. It hits the graph in this point, and I will go across to estimate from the graph, which is not easy and is not accurate either, right? To estimate from the cost of $10,000 from 1984 in 2010. So the cost will be, I kind of see it in the bottom half. So if this is 20, in the middle is 22, I'm going to say roughly 21,050 or 500. Sorry, 21,500. I don't know if that's correct, but this is where I estimated, right? So I don't know if it's exactly in the middle. I think that this piece is a little bit bigger than this piece. So I'm going to say somewhere between 21,000 and 22,000. Because this is 20,000 and this is 24,000. I'm sorry? Oh, sorry. I'm sorry. Okay, so 2010, and I go across. This is 20,000, this is 24,000. I don't think it's exactly at 22, which will be exactly in the middle. I think it's somewhere between 21,000 and 22,000. Is that okay for part A? For part B, use model 1 to determine the cost in 2010. How well does this describe your estimate from part A? Okay, so now it appears to be kind of clear. They are looking at this model, although this is not what they graphed, right? To see if another model will give us a better approximation. Okay. So use the model 1. So what do I need to do with model 1? And then for model 2, because it's the same thing, use model 2 to determine the cost. How well does this describe your estimate? So our estimate was between 21,000 and 22,000. Okay, so what do I have to do in order to determine the cost? So C represents the cost X years after 1990.
So X is years.
After 1990, and we are talking about 2010. So how much will X be? 20, very good. So all I have to do is, in this cost, replace X by 20, and in this cost function, replace X by 20. Whichever of these two gives me a closer number to what? To 21, between 21 and 22,000, I will say that is a better model. Does it make sense? Okay, so let's plug it in. I didn't copy the models. Okay, so C was, I'm sure I have this. Which page is that?
122.
122. And this is the same book, right? This is the same book we're looking at.
Yeah.
Okay, C442X multiplied by 20 plus 12969. And this is C1, and let's say C2 will be 2 multiplied by 20 squared plus 390 times 20 and plus 13126. Our estimate was somewhere between 21,000 and 22,000. And let's see what we get. And I do have, oh no, I turned it off. Why did I turn that off? No, I think I did not activate it. Okay. So I have 422, 442, sorry. That's what I thought. So 442 multiplied by 20 plus 12969, 969. And we got 21,800. I like this amount. And let's see the other one. 2 times 400, because I know 20 squared is that, plus 390 multiplied by 20, and plus 13126. 13126. Okay. So obviously it kind of makes it difficult because the difference is so small, 21,800 and 21,700. I would rather say that this is closer because it's closer to the middle. This, although the difference is so small, kind of difficult. So I would go back to the book and I probably would look at what the magnifying glass. I don't think it should be that difficult, but I would say that both models, they represent the answer quite well. I mean, they're both close to 22,000. So I wouldn't be able to say which one is better. They both model what happens around 2010. I don't know outside. I don't know at 2000. I don't know at 2030. That I can say. But my answer would be here that at 2010 or during 2010, both are reasonable. because my estimate was somewhere between 21,000 and 22,000, and obviously closer to 22,000. Closer to the middle. Good, very good question. Is this clear? So what did we learn from this example? To read the problem carefully, to analyze the graph and see what it tells us, to make sure we understand what does the x represent, the x variable. It was number of years since 1990. What the y variable represents and what is the measurement unit. What the graph was telling us, an uptrend starting from this point to this point. Okay, a lot of things we understood and we learned from the graph. And then we were given two models. We plugged in the number of 20 years. We were asked to also estimate from the graph. So when x was 2010, it hits the graph in one point, and we were able to read an approximate value for the y value. We learned a lot from this example. Thank you for bringing this up. Perfect. Anything else? Is there anything else we need to look at? Anything else? Anything else? I'd like to quickly go back to our lecture from last time and see if you have any questions on that. And then we'll continue. Please work with me every day. Don't say, today I'm busy, I'm not going to do any math. Thursday and Friday, I have my friends over from, I don't know, out of state. Don't do that. Please diligently do some work every time, every day. So here's my lecture notes from last time. We were looking at graphing a function. We remember when we graph a function, there are very important steps to remember. First, I have to identify the type of function. It could be anything. This was an absolute value. Then I have to identify the domain of the function. Then I have to present a table of values. Please get used to this because we're going to use it in chapter 2. We're going to use it in chapter 3. It's extremely important to be able to present the ordered pairs. It's very important to present the domain. I don't want to just see a little chart with x equals 5, x equals 3, and x equals -2. That's not enough. You have to present the domain of the function, and you have to show the ordered pairs. By picking x values, you determine the y values. And then I need to see these plotted somewhere on a coordinate system, okay? So please follow the step-by-step. It's a very clear-cut step procedure. So then we graphed, and the range was determined after we graphed it. And then we looked at linear and rational equations. So this was a linear, this was a rational equation that we discussed last time. We have two more from today. The restrictions, moving terms around, finding the adjustment. I call them adjustments. You can call them the way you like, the x minus 1, the x plus 1, and the 1. Combining like terms, changing into a proportion, cross-multiplying. It's a linear equation now, and we get x equals -3. What I forgot to mention here, because it was clear, but I should have mentioned, I have to go back with this 5/4 and make sure that it's not 0. Well, it's not 0. I have to go back with 3/4. I have to make sure that it's not 0. It's not 0. So I'm expecting that that is the correct solution. And you can say, what if you made an error somewhere? It's possible. It's very possible. But if you don't state restrictions, you have to go back and check. Okay, so it's one or the other. Okay, going back to our lecture from last time, we had the second rational equation, step by step. Please remember, this is crucial. This is the very first step. Redo the problems we do in class. Okay, then we started quadratic equations. And please remember, moving forward, I would like to see your work every time. So at the beginning of the class, for a few minutes, I will pass by each and every one of you, and you show me what you did. And next time, I want to see 1-1, 1-2, 1-5, and the beginning of verse 6, maybe. We'll see in a moment, okay? So this is for Monday. Please don't forget that. Okay, so we started with quadratic equations, and we said there are 4 different methods, and we only looked at one. And that was not enough. So we're going to start from here. Any questions for me? Any questions? Also, yes, go ahead.
Oh, I just wanted to see,
Yes?
I bought one of those online, I was trying to see, is it different in the book, or is it
The
same
book is
thing?
the same. There is a copy in the electronic.
So that's, we could get either one?
You have to get the My Math Lab code because the homework is there.
So you have it, right?
I don't know.
You do not need a hard copy of the book.
So basically, I went to the bookstore and it was like, so they had it, I told them I want the online.
Okay, if you remember last week, maybe you were not here. Were you here Monday and Wednesday last week?
They should have gave you something additional steps.
It's inside the book itself.
No, they just gave me this.
No,
It's
I got that exactly.
It's like
So you
that.
register
It's
the
like that.
instructions.
Yeah, that's what I'm saying.
Yeah, you register the
And that's
instructions on there.
this, and then
Yes.
you gotta, it's literally step by step, so you go to this, and then you're gonna give you a code, and you go there, and you give you another
So
code.
is that the right thing, like, right?
Yeah, that's correct.
Why do you?
'Cause
Okay, so here it is. Look here for a moment. So you go to My Labs and Mastering after you log into your course. You know how to log into your course.
Yeah.
Everyone knows how to log into the course. Okay, perfect. So then you go to My Labs and Mastering. You see this link, My Lab and Mastering? So you click on this, and it will take you from there. It will tell you what to do step by step. Once you're in, then in order to access the book, you have what is called Multimedia Library. You click on Multimedia Library, and this is an electronic copy of the book. So now let's say we are in chapter 1, and we are looking today, we're going to be looking at we're going to look at quadratic equations. That's what we're doing now. Select all, click on select all because you want everything. You want PowerPoints, you want videos, you want to select everything. So then you click on find now. And here it is, quadratic equations. Okay, so now I'm going to take you back. Careful with these pop-ups because you have to disable them, otherwise you will not be able to see what you're trying to see. Okay, so here is your colleague's question a minute ago. Here it is. I'm just going backwards. Oh, actually, it's in 1.2. This is a new system, and I have not been able to figure out yet how to punch in the page number that I want to go to. But I'm sure you will before I do. So this is 1.3, 1.2. That's what I want to just show the graph. Here it is. Here's the problem with the cost of inflation. And these are the models that we looked at a few minutes ago. And this is the question. Question 99. And this is what we wanted to determine. Okay? So this is it's an electronic copy of the book. Anyone else has difficulties with this?
What about the math lab? Somebody said.
This is My Math Lab.
Oh, that's it.
This is My Math Lab. So once you're out of there, go to the left column. Everything is in your left column. You go to, I'm not sure what's happening here. Okay, Assignment Manager. This may be slightly different because as a student, you probably see something else.
It says one more fast break.
Right, so for example, what we're going to look at, quadratic equations is right here, and you will click on the quadratic equations and it will open up as an assignment. Anyone else has questions on My Math Lab? Okay, perfect. So anything else for me? Anything else? Okay, so we know what the homework is due on Monday. When we talk about quadratic equations, if you remember, I gave you this handout at the beginning of the class. What I would like you to do, because I need to verify that everyone knows factoring. So go to the factoring document. And I have selected a couple of problems for you. Do you all have the factoring document?
Yes.
Perfect. So in the first section, I would like you to work on A, B, C. First section in the factoring document. I will scan this and post it also for you tonight when I finish. I have one more class after this class. Okay, so from the factoring document, everyone has factoring document. A, B, and C. Yes?
Mhm.
Have you been to this class before? Is this your first day? We have to talk about what you need to do at the end of the class. It's a long story. It's not just one document. Okay, so A, B, C, E, and F. I just would like you to pay attention and not play with your cell phone, though.
On my laptop.
Okay.
Laptop.
Okay, then you are allowed. That's perfect. So A, B, C, E, and F. Then from the next section, A and B only. From the next section, B and D. B as in boy, D as in Dan.
Mhm.
Yes, B and D from the bottom section. Now on the next page, top section A and C. The next section A and B. So the top A and C. The next section A and B. And from the next three sections, I want you to choose one problem from the first, one problem from the second, and one problem from the last. Please always bring these documents with you all the time. Yes. Okay. I'm going to post this tonight in Canvas. Yes.
I'm sorry, for that bottom 3 and 4, is that?
One of this, one from here, one from here.
No, just any of your choice.
Any that you like. Yes. I hear the cell phone, I see the cell phone. When I see a cell phone, I'll invite you over to work on a problem. So please put it away in your backpack or purse, please.
When do you want these done?
Monday next week. All these, yes, yes.
So how many assignments do you on Monday?
I'm sorry.
So how many assignments do we have that are due on Monday?
These three sections, because I need to see them. But you have done the first two because they were due today. So these two, the first two are done today, for today. So I'm adding one more for Monday, and I'm adding these, plus the rest of the homework. That's what I'm saying. I would like from the very beginning to discuss studying habits, form study groups. So help you. I need to help you from the very beginning because a month from now is going to be too late. Okay? Yes, please. Those are due after each class, but after you redo the problems we do in class, after you read the section and redo the examples in the book, and after you select problems from these. And then you will be ready to do homework. If you just go home and try to do homework, it's not going to work. You're going to have difficulties from the very beginning. Yes. Hold on, just 1 second. 1 second. Is that clear? You don't understand how you need to study before you do homework? That's a problem. We have to talk about it.
That's what I'm saying. In the book, it says assignments, right? Is it the same thing that you're talking about homework?
This is additional.
So when you say assignment, you're talking about my math lab?
Mhm.
Before you get to that, you have 3 steps to perform. Don't even look at those. You have to perform 3 steps before you look at that homework. Step number 1, you have to redo all problems we did in class till you understand them and you can reproduce them on your own. Step number 2, after that, you have to look at the problems are solved in the book. For example, from section 1.2, we have example 1, example 2, example 5. See, this is a rational equation. Looking at this, if you like the method, use this method. So you have to solve all the examples in the text. And after that, step 3, if you can get a good grade in this class without doing this, I'm fine. I'm fine. But the grade will reflect what you're doing. Trust me. And then you have to do half of these, half of these, half of these. If you follow my directions, when you're ready to do homework, it will take 5 minutes because you already studied. If you're not following my directions, you will sit down in front of your computer, you'll be on the computer, you'll open my math lab, and from the very first problem, you will not know what to do. You will go back to the book, back to the notes, it will take you an hour, and you will be upset or get upset and say, oh, I can't do this. But if you're following what I'm asking you to do, the homework will take little time. You will not have difficulties with it. Because you already did the groundwork. This is my recommendation. And then you will not have any difficulties with the tests or the final exam. It will be a breeze. Try what I'm asking you to do, and if it doesn't work, it's my fault. But if you are doing something else that you think it works because you have experience in the past and it works, I'm fine. I'm fine.
Okay. So
Hold on one second. Yes.
on the assignments on my math lab, so we should have already completed those.
They're not due yet. But if you wait till 5 minutes before the test, you're not going to be able to complete them. So that's why I want to do them sequentially. We finish a section, we redo the problems, we do the examples, we check with some of these in the back of the book, our understanding. Hold on. I'm answering a question, please. So, and then you do your homework. And then we move on. Always take notes or new ideas. Like your colleague said, okay, you haven't showed this, and she was right. So we didn't get the chance to. So she had a problem. We worked on the problem. Now we have an idea about that too. And that should help us move forward. I'm here to help you. If anything else works for you, I'm fine. But trust me, I have a 22-year experience with this class and other classes. If you're ready to put the work in and the time invested in your knowledge, you will do very well in my class. I bend over backwards to help my students. You'll see. Yes, sorry about that.
Yeah, that's fine. So what I want to understand is, so what you're giving us is a recommendation to follow. Not like
But I will write it down every class. I will go from one student to the other, and I will say in my notes, Jessica did not do anything for today. Sections 1.1, 1.2, and 1.5 were due, and I did not see any work, and this is today, September, blah, blah, blah. And at the end of the semester, we'll compare notes. And I'll say, and if you say, well, I failed the first test, and I'll say, here's why. I didn't see any work on September 1st. I didn't see any work on September the 5th. I didn't see any work. I didn't see you during my office hours. You didn't come for help. What can I do? Not you. You understand what it's an example. Okay, other questions for me? Okay, good. So let's continue now and try to finish section 1.5, which is quadratic equations. We looked last time as only one example, in which we took square roots from both sides. So let's analyze a couple of problems. So this is section 1.5, and I am on page 167, and I would like to look, let's say, at problem 22. 67, sorry. And we have x minus 3 everything squared equals 36. So I'm kindly asking you to not to forget about the factoring situation, because I would like not to have to go over it unless there is a need. So I'm hoping that you are going to come up with these solutions by Monday, so we don't have to spend more time on factoring.
You said page 167, number 22?
Yes, 22 on 167, yes. Okay, so obviously I have to ask myself what type of equation this is, and of course it's quadratic. Then I'm asking myself, there are 4 methods, and I repeat them. Factoring, it's already factored. Taking square roots, yes. Why? Because I have an expression with x, everything is squared, and the number on the other side. And the other 2 we haven't discussed yet, right? So this is typical for taking square roots. How do I undo power 2? Well, I undo power 2 by taking square roots from both sides. Once I say that the equation is quadratic, how many solutions do I expect? Mandatory 2. They may be the same, I don't care. They may be real, I don't care. They may be imaginary, I don't care. If it's quadratic, which means degree 2, we have, bless you, we have to have 2 solutions. Very good. So if you remember, I said last time that when we take the square root from something squared that has a variable inside, then I should write the absolute value of x minus 3. Instead, I would write x minus 3, but I cannot omit something on the other side that will actually replace the absolute value. What do I have to write on the other side? Thank you very much. And how much is the square root of 36? 6. Is this done? No, because I have to solve for x. What will be my next step then? Yes, but I will not add it to the right, and I will not put it in here. That will be wrong. I will not put it here. That will be correct, but I would like to put it right in front of the plus or minus. So this will be x equals 3 plus or minus 6. And now I do have to separate. I do have to separate the 2 equations, the 2 solutions. The first one is 3 plus 6. The other one is 3 minus 6. What are the solutions here? 9 and negative 3. And this is how the method of taking square roots works. And let's look at one other problem. You are going to hear me say a lot, in short, clean the equation up. What do you think I'm really telling you when I say clean it up? As much as possible. Awesome. That's all I needed to hear. Very good. So here's one other example that I would like to look at. Let's say 24. On the same page, 167. And this is 3x plus 4 squared equals 21. So this is an equation that is not completely cleaned up. What do you think we should do in order to clean this up, or simplify, in other words?
Multiply the 3 by
Can I do that? Can I distribute 3 inside of?
No.
No. Why?
Because the exponent is
Exactly. Because by the order of operations, this has more power than this, right? So please do not ever try to distribute inside parentheses when there is a power. You cannot do that. Is that clear? It's okay. We are here to clarify things. So don't be embarrassed or, scared to say something. So now this is clear, correct? Good. So there is a way of cleaning it up or simplifying it. What will I do then? Exactly. As you noticed, this particular one was very, very straightforward. There was a 1 in front. I didn't have to deal with anything. But in this case, there is an additional number in there, and I had to just looking at the time.